What's up, everyone? My name is Jeff. This is Jeff Brown Tech. This is the next module in the PowerShell Command Line 2 Scripting course. If you're just coming across this video, go ahead and check out the video description for a link to the full playlist. It contains newer videos and then other videos I've done in the past to reinforce some of the concepts we're going over. This is the module talking about flow control. This is probably one of my more favorite modules because we really get into the logic and controlling the flow of our scripts and making decisions, and really bringing out the power of scripting and programming to do multiple things and make decisions inside of our scripts. Let's go ahead and take a look at our README here and see what we're going to cover inside of this module. Here inside of Module 2, we're going to learn how to control the behavior of our scripts using conditional logic and loops. A couple of things we'll learn is if, else if, and else statements, how to repeat tasks using for and ForEach, while and do while loops. We also have switch statements to handle multiple conditions more cleanly. We'll take a look at infinite loops and how to stop them, and then combining control flow with arrays, strings, and numbers for some practical tasks. We have 5 different lessons here covering those different statements and loops and making decisions with our switch statements. In each of these, I do have small exercises for you to complete to reinforce the concepts. I have a challenge for you to create a game where you have to interactively guess the number that the computer has chosen at random. Of course, down here at the bottom, we have the course navigation. You can go back to the variables and data types module and then continue next into script parameters. That does it for our introduction. Let's go ahead and close this out and open up our first lesson here with if, else if, and else in our Jupyter notebook here. First, let's talk about if, else, and else if statements. These allow you to execute specific blocks of code depending on if a condition evaluates to true or false. True or false are Boolean values. Those are built in. You don't have to define them or anything like that. We've talked about that in the previous module. Let's get started with the very basics of this first and talk about our if statement. If statements will execute a block of code that is contained within curly brackets if a condition is true. Let's just jump down and take a look at our example statement here. We have a variable defined called number, and it is equal to 10. And let's just go over the syntax here. We have our if statement. Inside of our if statement, we have some parentheses here. That is the comparison that we're making. And then if this evaluates to true, we have our curly brackets here. This is everything that will execute if this statement is true. Now notice inside of our condition statement here, we have a comparison operator. We took a look at these in our previous module when we talked about variables and data types. What we are looking at here is number. This is our variable, and we know this is 10. So let's just overwrite this with 10 here. Is 10 greater than 0? That's a true statement. The number 10 is bigger than 0. So this would evaluate to true. And output to the screen would be a statement that 10, which is the value of number, is greater than 0. We have another if statement here. We know number is equal to 10, so we'll just write this in here. Is 10 less than 0? Nope, that is false. 10 is not less than 0. We already established that it is bigger than 0. That means the statement will evaluate to false. And then we will not see this displayed to the screen because this did not evaluate to true, so this code block will not execute. And again, we have number here, 10 is 10 equal to 0. We know that is false, and this statement will not execute onto the screen. So let's go ahead and execute our cell here and see what pops up. And we see that 10 is greater than 0. We already established this first if statement is going to execute, and the rest of these will not. Let's go and change the value of our number. Let's say -5. We'll execute this. We see -5 is less than 0. That is our second if statement here executed. And then if we say 0 exactly, the number is 0. This is just illustrating how these if statements execute if they evaluate to true. And we just saw that only one of them executed as we changed the number variable to different values. Not all of them executed. It's only based on if it comes out to true or not. Now, what if we have an if statement, but it doesn't evaluate to true? Can we take another action immediately because it's not true? This is where our else statement comes in. The else statement executes a block of code if no other if condition evaluates to true. We do have an updated code example here. Notice how this else statement is defined after our if statement. The top part of this really hasn't changed, if, and then we have our condition here inside of parentheses and then the curly brackets for that code block. But if this statement here evaluates to false, we'll just put false here, and everything inside of its code block will then execute. Essentially just going through and saying, if this is true, we'll run this, else if that is not true, then we are going to run this other part down here. Let's take a look at what we have here. We have number is -10. We know this is our value here. Let's just write this in here. If -10 is greater than 0, well, that is false. That is a false statement there. That means we are not going to see this output, and it is automatically going to come down here and put out that -10 or our number is less than 0. Let's go ahead and evaluate this. And that comes out as accurate. It says -10 is less than 0. And if we go change our value here to 10, it will output 10 is greater than 0. Now in our note down here, it does say there is a small logic issue with what we have written out here. What if our number variable is equal to 0? It will output 0 is less than 0. Let's go ahead and take a look at that. So we'll put 0 in here. 0 is less than 0. Now, why does that happen? That's because if we go in here, our number is 0. 0 is greater than 0. Well, that is a false statement. And it is going to automatically go into our else statement here and say it is less than 0, which is actually not true because our number is 0. Now, how can we maybe have multiple if statements in order to check to see if the number is 0 in this case? This is where our next component comes in with else if. The else if evaluates another condition if the previous if or another else if above it also evaluates to false. We have an updated code block here with this in mind. Let's go ahead and go through it. First, our number is equal to 10, so we'll just overwrite this here to illustrate what it is. If 10 is greater than 0, that is a true statement. Perfect. And then we'll execute that right there. 10 is greater than 0. Let's say 10 is not greater than 0. We have an else if statement here. We have our keyword else if, and we can make another evaluation. We have it here inside of our parentheses. Is our number less than 0? Number is less than 0. But let's say this is also false, then we'll fall all the way to the bottom here and execute our else statement. Now that we go through, let's go ahead and execute this and see what outputs here. We can see 10 is greater than 0. Perfect. Let's go ahead and make this -10. We'll evaluate it again. -10 is less than 0. That's because our first if statement here evaluated to false. Then we fell into our else if statement and we outputted that there. And if we were to go through and put 0 in here, it's going to say the number is 0. That's because we came in here, is 0 greater than 0? That's false. That did not execute. Is 0 less than 0? No, it's not. That's also false. So this did not execute. And then we ran into this one because everything else was false above it. And we said, well, at this point, the number must be 0. Next, let's go into a section I called Fast Facts. Just a couple of things to know about if statements. Once a condition evaluates to true, PowerShell does not continue checking the remaining else if or else statements. What does that mean? Let's go back up here and take a look at this, where our number was 10. What this looks like is we saw here 10 is greater than 0. If that's true, perfect. It executes this code block, but then it just ignores the rest of this. It is not going to continue checking to see, is that number less than 0? Do we need to go into our else statement? Once we hit a true evaluation, the rest of our compound kind of if statement here will not continue executing. Now that is a little bit different than our first example up here. Let's go all the way back to the beginning. Here we had separate if statements. So we had number 10. Is 10 greater than 0? That's true. And this is going to output. Now, since these are separate if statements, PowerShell is actually going to check these. It's going to go, oh, is our number less than 0 now? is it equal to 0? When you have separated statements like this, it will go through and evaluate each one. It doesn't matter what they evaluate to, since they're all separate statements. If we go back down here, again, once this one evaluates to true, it's not going to go through the rest of them. But let's say this first one is false, and then this one is true. Then it stops. There's no reason to go into the else. And again, let's back up here. If this one is false, then we have our else statement, which it automatically falls to. It's almost a default at that point, and it will evaluate this one. And as we've already seen, the else block does not have a statement. It will only run if everything else is false. That's semi-related to our first statement here. If we're going through and we come across a true, it's not going to continue, but if everything is false, it will evaluate the else block. And then PowerShell will automatically treat your non-Boolean values as true or false in an if statement. What we have seen previously is we're evaluating a condition to true or false. However, there are some times where you can just put a variable or a statement or something into the if part of this inside of the open parentheses, and PowerShell will make an evaluation on it that's equivalent to true or false. We do have something here called truthy values. These are non-zero numbers, non-empty strings, and non-null objects. Then we also have falsy values. These are things like null, 0, an empty string. These are double quotes here, but there's no space in between them. And of course, our false Boolean variable here. For example, if we were to say if hello, this is a string. The string has characters in it. This will actually output because the string is not empty. If we say if null, which is just an empty, it's empty, it doesn't exist or anything like that, this will not run because null is false. And if we say if 0 is equivalent to false, it's not going to run because 0 is false. If we were to take the cell, we should only see one output. This runs because the string is non-empty. If we were to go back in here and take out hello and run this again, we shouldn't see any output. Essentially, you can take things like this and, for example, you might run get user and save that to a variable. You can then say if variable and put the variable value in here. If that variable has a value, it would evaluate to true and execute that code block. But if you ran get user and it didn't return any users or get item, or you're trying to search for something and it comes back empty, if you say, if user is the name of your variable, it will base an evaluation on it if it returns something or if it has a value. If we continue on, you can do multiple conditions using our and or. We saw this in a previous module. We were doing different things of evaluating numbers, is this number greater than that, and doing math and everything. But you can use these inside of our if statements here. So let's take a look. Let's say we have age variable is 25. We have has license is true. We have our Boolean value here. As soon as you see the dash and here, what we want to do is maybe just separate these into two separate conditions here that we have to evaluate. Age is greater than or equal to 18. We know 25 is greater than or equal to 18, so this is true. And has license, we know this is true because it's a Boolean value and we already have it set, so this is true. And we're going to write output that you can drive. Again, we're putting compound conditions here that we want to evaluate inside of our if statement. Next, we have two different variables here. Weather equals rainy, time equals day. If our weather equals sunny or our time is equal to day, we're going to output you can go outside. One of these has to be true for this to evaluate. In this case, weather is rainy, so we know that is false. However, the time of day is day. That's true. And it's going to output you can go outside. Let's go ahead and run these. You can drive, you can go outside. You can have pretty complex compound statements here in what you're evaluating. For example, let's look here. We have an or statement here, but then we also have an and these two are combined together with these parentheses right here. Sorry, let me erase that here. We have a parentheses here. What's going to happen is it's going to evaluate this and condition first on this side of the or, and then we're going to evaluate here. Our temperature is 40. 40 is greater than 30, so we know that's true. And our temperature is less than 50. That's also true there. So this entire condition here evaluates to true. Or wind speed is less than 10. That is also true. We're going to output nice weather. Let's just verify that. Nice weather, perfect. And we learned about our not operator before. It just negates whatever condition is evaluated there. In this case, we have is ready is false. This will end up evaluating to true because we're looking for the opposite, not, or rather is ready is false. But since we have the opposite here, which goes to be indicated by an exclamation point, this is going to evaluate to true. And it's going to output our statement saying not ready yet. We've already talked about how PowerShell is not case sensitive. In this case, when you're comparing strings or anything like that, it's normally case insensitive. But if you need to do case sensitive operations, you can add in the letter C here to a lot of operators, which means it is case sensitive. So in this case, since we're looking at equal and we add a C in here, we want to make sure it is case sensitive. We have our string here, hello, that is in all capital letters. String equals hello. This will actually evaluate to true because the strings themselves, even though they have different casing, are the same letters. However, when we put C in here to say case sensitive equal comparison, that is actually going to come back and say no match. Now, we've already seen before when checking a Boolean value, you don't need to compare it to true or false. We saw before is running equals true, and we'll go to the second part here. If is running, we know is running is equal to true. That is going to output running. But it is perfectly valid to compare this and say is equal to true and then execute whatever statement you need to. What this is just pointing out is these two statements are doing the exact same thing. The second one is just a little bit simpler because it is a Boolean value. If is running equal to false or not running, again, these two statements are equal. This one being if not, saying if not true. I did put a note here. There's some debate whether to always include a true-false comparison against Boolean values. So what I'm saying here is these first examples like this. Some people argue that it makes reading the code easier, while others say it's not necessary. If you ever watch anything with Jeff Hicks, who is a PowerShell expert, he will always advocate for including these comparisons here and being very explicit, because he has come across some edge cases where this had to be included for this evaluation to happen. Everyone always has strong opinions. If it makes more sense to you to put your value in and say equal to false or equal to true, and that helps you read the code better, go ahead and include it. There's nothing wrong with it. Just understand some people have opinions that that's a wrong way to do it. But, if it works for you, that's what you do. I don't see any harm in doing it. But just also understand if you come across something like this where it is just an if statement and a variable, that's probably a Boolean value, and these are equivalent statements there. That does it for talking about if, else, and else if. I do have a small exercise here for determining letter grades. What we're going to do is take the knowledge we just learned about our if statements and determine a student's letter grade based on a score, then output a message telling the student what their grade is. I did include a handy chart here for showing our letter grades. If it's 90, between 90 and 100, that's an A. 80 to 89, that's a B, and so on. I do give you a little cell here. If you're not ready to go out and create a script file, you can do it directly within here. I start out by giving you the score variable and setting it to a value. You can output your code here below that and execute the cell to see what happens. And then change your score and test different conditions to make sure your logic is working. For this exercise, if you want, pause the video. If you have this code downloaded or this repository downloaded, you can sit here and use this cell here to give this a try, and then come back and we are going to go over a possible solution. Let's go ahead and select that. And before I select on this, I want to make sure under each module, I do have a solutions folder. If you expand that, it'll have solutions to different exercises and challenges we're doing within the module. To get started here, I have a score of 75. This is a solution using single statements. I do have a note here. We'll come back to that note in a second. We know our score is 75. Is 75 greater than or equal to 90? That's not true, so let's go into our else if. 75 is greater than or equal to 80. We also know that is false. Let's go into our next else if. Let me write this up here and be consistent. 75 is greater than or equal to 70. We know that's true. It'll output you made a C. Now that we've hit a true condition, we know the rest of this is not going to evaluate. Now, this code here does work, but I do have this note here. It does not handle scores greater than 100, and you can end up accepting negative scores. If I were to put, person made 105, I guess technically they made an A, but it's extra credit, or maybe, you don't do extra credit and that's not a possible grade. That's a minor thing, but I could accidentally input in here -10, and that'll output you made an F, but that's outside the bounds that we put inside of the challenge where 90 to 100 is A, and then 0 to 59 is an F. While this is pretty good, we could do a couple of improvements. So down here, I have a second variation of what we can look at. This is where we're using compound statements. Our score is 75, so is 75 greater than or equal to 90? Well, that's false. Now at this point, we see that this is an AND, so we could just go ahead and continue, but our score is less than or equal to 100. We have a compound statement just absolutely verifying it's between 90 and 100. Same thing, 80 to 89. And then we know at this point our score is 75. It's going to output here to C. But if we continue with our compound statements, 60 to 69, and then 0 to 59, and we added an else statement here, if our condition did not fall within one of those, invalid score must be between 0 and 100. As you're gaining these script writing skills, it's also a thing to think about how to validate user input and ensure that the input or data that you're getting, you handle it in a specific way. And this example is a good way of looking at it. When you first start writing things or you're getting used to these conditional statements and everything, this first example is something you might come up with. But then if you start testing the different values, you notice, oh, I'm running outside of bounds of the conditions of what I want. Then you come down here and start handling it and thinking, how can I make sure that the data I have is good? And that's what this second part does, is we're being very explicit, making sure we're between 90 and 100. We don't go over 100, and also making sure we don't go below 0 and how to handle that. Okay, that finishes up our first section here. Let's go ahead and close this out here. I'm not going to save my changes. And let's go talk about for loops. Now, for loops are used when you know how many times you need to iterate or loop through a list or array or a certain number of actions. There are 3 different parts to a for loop. First, you have an initialization. This is where you set up a control variable that you're going to use to evaluate how often your for loop is going to continue looping, basically. For example, you have $i equals 0. These loop control variables are typically a single character name variable, might be n or I or something like that. We then have our condition. This is defining when or how the loop should continue or when it should stop running. In this case, we're saying our control variable, which is I, which we defined right back here, as long as I is less than 10. Sorry about that. There should not be a space here. I'll clean that up later. We know this with our comparison operators that that's all, a single string basically. And then as we iterate through the loop, we need to define how to update the control variable each time the loop completes. In this example, I'm saying I++, that should have a $sign on it. And we know ++ means we're just adding 1 to our variable. And then we have our syntax for our for statements. We have the for keyword, and then inside parentheses, we have our initialization, which we just talked about here. We have our condition, and then our iteration. These are divided by semicolons. We have our curly brackets for our code block, and then what we want to execute each time we're going through our for loop. Now, I know that's a lot of different components. Let's go ahead and take a look at an example and see what they look like when that all comes together. Here we have a code sample. Our for loop defines a loop control variable $i with a starting value of 1. So that is this component right here, our initialization. And then we have a semicolon to separate it from the rest of our for loop defining statement. Our loop condition will run through while I is less than 10. So here is our condition. $i variable is less than 10. So we're comparing that each time we go through and loop. And then after each loop completion, we're adding 1 to our variable using ++. And all we're doing inside of our code block is we're outputting the current value of our control variable here. Let's take a look. Let's run this code and see what it looks like. Okay, this is the first time this is happening. I've mentioned in the introduction video that sometimes when you go run these cells inside of these Jupyter notebooks, you have to run the cell a couple of times maybe to get the output you want or clean output. And sometimes it will prompt for what kernel you want to use. We have the PowerShell kernel installed here, so we'll go ahead and select it. And then it executes the code. What exactly is this for loop doing? And we've talked about its components and everything, but now we can see the output. So let's take a look at it. So at the beginning here, we have I is equal to 1. While I is less than 10, that's our condition. So 1 is less than 10. That's true. We'll come back to this part here. We've evaluated our condition. 1 is less than 10. That means run what's inside the for loop. We're just outputting a string here. The current value of I is 1, and that's what we see here. Current value for our $i variable is 1. Now that this loop has completed one time, we are going to go through and add 1 to I. So now this is 2. I'm going to kind of output it there. Let's evaluate the condition it in. 2 is less than 10. That's a true statement. We execute our block of code here and we see it outputs 2. Next, I'm just going to write over here. We have I. Let's actually write this up here. What's our current value of I? I is now 3. 3 is less than 10. That's true. Outputs our code block. We add 1. It's now 4, and so on and so on. Now notice we get down to 9. At some point, I is going to equal 10. Put this here. Is 10 less than 10? No, it's not. That is now false. That's going to output false here, and our code block does not run. And then we continue on to whatever the next part of the script is. So again, all you're doing is you're defining your control variable, I, setting it to a value. You're doing continuous comparisons after each time your for loop completes. And then you need to change your control variable in order to keep evaluating your condition till at some point it evaluates to false. And we saw that here. Eventually, when I was equal to 10, it was our condition here. It was no longer less than 10. And we don't see 10 outputted here because evaluated false and our for loop is done. When you start working with things like for loops, and we'll see while and do while loops later, you can run into infinite loops, meaning they will continue running forever until you stop or shut down the process. What you want to make sure is your condition and your iteration definitions are correct. Those are make it or break it for your for loops. If you incorrectly define those, the loop can continue running, or if you fail to update that control variable, it will just run indefinitely. And if you're not aware of it, in most consoles or languages and everything, if you hit Control-C, it will stop the execution of whatever is happening inside the console there. Let's go through a couple of examples where our condition always evaluates to true, resulting in an infinite loop. This first example, we have our control variable I. It is equal to 1. 1 is greater than 0. That's our condition that we're going to evaluate. And then we're adding 1 each time we complete here. Let's go through and think about this. Let's write out I, and we'll keep track of its value here. I is 1. Is 1 greater than 0? That's true. We're going to output that to the screen, and then we're going to add 1 to it. Okay, so I is now equal to 2. Is 2 greater than 0? Yes, it is. Add 1, or output to the screen, add 1 to it is 3. So hopefully you notice what we're doing here. If we're always adding to our control variable here, and that's going to always be greater than 0, this is just going to continue on and on and on, and it's never ever going to stop, because we started out with this being true, or our number is over 0 and we're only adding to it, so it's always going to be greater than 0 until we run out of memory, or it hits the max integer value. In this case, we might need to do something other than, this maybe needs to be 10, just like we saw in our previous example. We just need to go back and see what we're trying to accomplish and either fix our condition, maybe fix our starting value, or change our counter here, what we're doing with it. Here's the next example of an infinite loop. We have I equals to 10. So let's just put this out here. I is 10. 10 is greater than or equal to 0. That's true. Go here. And then again, we're adding 1 to it. So this is then going to turn into 11. And again, 11 is greater than, we're only moving further away from our condition here that we want to eventually evaluate to false. So we're going in the wrong direction. In this case, what we probably ought to do is, instead of plus plus, we would say, let me back up here. We would say minus minus, because we want to go backwards or go down. That would result, let's say I equals 10. 10 is greater than or equal to 0. And then it would decrement it into 9. 9 gets us closer to making this evaluate to true. And then here are just some syntax things that can happen when you're defining your for loops. In this case, our for statement, or we're missing our condition here. This is technically possible because you're putting in your semicolons here to separate out your different values and everything. Since there's no condition, it would just continue evaluating just fine. Here we're missing our iteration statement of what we're doing with our control variable. Are we adding to it, or are we subtracting to it? We have another example of an incorrect for statement here. Let's take a look at it and see what we can do to fix it. We have our initialization variable I. It is equal to 10. Let's take a look at our condition here. Is 10 less than 10? Well, that evaluates out to false, which means our for statement here is never going to execute. Essentially here, we just have an incorrect statement, or maybe an incorrect counter variable here. Let's take a look to see what we can do to resolve that. I have a couple of solutions. Like I mentioned, I is initialized incorrectly. Let's say I is actually equal to 0. We say 0 is less than 10. That is true, and that would go through our code block. If we then add 1 to it, it would equal 1. 1 is less than 10. That's true. Go through our code block, we add another 1, 2, and so on until it is less than 10, or while it's less than 10. Once it equals 10, our loop is done. Another statement here, or fix we could do, is change our condition statement. Let's say we up this and increase it to 20. Our variable 10 is less than 20. That is true. That would go through our code block. If we add 1 to it, it's then 11. 11 is less than 20, and so on. And as we continue to increment I, as long as it's still less than our condition here, we are good to go. Your initialization variables and your counters, they don't necessarily have to start at 0, 1. They could be another different value, as long as your condition is correct and you're incrementing or decrementing your condition variable correctly. Next, let's talk about using for loops with our arrays. Now, if you remember about our arrays that we learned about in the first module, they are 0 indexed, and you can access items within your array using different indexes, and they start at 0. You can use 1, 2, 3, and access the different values. You can actually loop through arrays with this information because you can access individual items within that array using numbers, basically indexes. You can use those inside of a for loop. For example, here we have our fruits array with our 4 items. That should look pretty familiar. Now think about, we're defining our control variable here, I. If we start out at I at 0, well, that's kind of equivalent to our index 0 here. And as we go through and increase it by 1, that can give us access into our different array components. And then within our condition statement here, we have I is less than fruits. We know fruits is our array. And we know one of our properties of our array is the length, how many items are in it. And then we can access that here using our control variable, just like we were doing before. We have fruits. And then at this point, at the first run of this, I is equal to 0. So just imagine this here. That's our index, fruits of 0 index, and that will output to the screen, apple. And then we go through and add 1 to it. Our index here now becomes 1, our value, and it'll output banana. And this will continue until we reach the length of how many items in here. Let's just back up real quick. What I want you to think about is the length of our array is 4. So just substitute your fruits.length here with 4 and is less than, and that just gives us our number here. We'll go ahead and output this here, and it's going to output each item here. What I just mentioned there was our fruits is 4. But remember, our indexes start at 0, and this max index here is 3. So at the end of this is 3. As long as 3 is less than 4, that outputs mango here. We add 1 to our control variable. So this is now 4. 4 is not less than 4. That evaluates to false, and we stop going through the array. However, if you were to come in here and make a small typo or maybe a mistake and say less than or equal to, well, what's going to happen here? Let's just run it and see. We don't get any output because there is no 4th index inside of our array. I was actually expecting this to give us some type of index-based array error. But just know you have to be careful when you're dealing with things like arrays and you're wanting to iterate through the whole thing. Just make sure you get your comparison operator correct here so the number, the index, and the length of it match up. Now, for loops are really good for modifying your array contents. Here's our quick example here. Again, we have our fruit array, apple, banana, cherry. I is equal to 0. We want to make sure we start off at 0 if we want that first index in the array. Less than or equal to, this is all the same from our previous example. But what we can do is access or reassign values inside of our array. Here we're saying fruits of our current iteration. Let's say the first one is 0. We're going to change the value in that index. Again, fruits of 0. And we know our string methods here, we can say to upper. So going back through this, fruits of our current variable, our control variable, which in this case is 0, we're going to convert that to uppercase and then reassign it back into that current index. Let's just run this through and hopefully this will make sense. So if we go like this, we output it to the screen. We have now changed the value of the items in our array using a for loop, and now all of it is uppercase. This is where for loops and arrays really come together, is if you need to modify the contents of the array. It's very easily done using our control variable here because you're going through and accessing the array based on its indexes. Next, let's talk about strings. May not have mentioned this before, but strings are technically an array of characters. You have the word PowerShell here, but each letter in that string there, pretend it's an array and each of it is an index. So P would be 0, lowercase o there would be 1. And you can iterate through a string just like you would a regular array. We have our same evaluation statement here. I is 0, while I is less than the length of our string, just like we did the length of our array, and then adding 1 to it as we iterate through. The character at index, our current control variable, And then you can say text, which is our string here, and output our what letter is there based on its index. So like I mentioned, P is going to be 0, lowercase o is 1, W is 2, etc. We'll just go ahead and run this. Character at index 0 is P, index 1, and so forth. Again, just something to be aware of. A string is almost like an array of characters there. So think about what you could do here is if you were going through a string and you wanted to find uppercase letters, or you wanted to replace certain letters, maybe change their casing, just lots of fun little things like that. That does it for our for loops. Let's go take a look at short exercises here where we are finding even and odd numbers. I do have just the starter code here, and my goal is to output the numbers 1 through 10 and just say, are they even or odd? I give you most of the code here, but what I want you to do is define the starting value. We're going to take everything that's inside our brackets here, and I want you to update it. So figure out your starting value, figure out your comparison operator of when you want this for loop to stop, and then how to iterate through that for loop, what you want to increment the control variable. And just to be nice, I went ahead and put out the logic here of determining if a number is even or odd. We talked about this a little bit in our other module when we talked about operators. We're saying our current value of this variable, modulus 2, I mean, you're dividing it, but you're taking the remainder. If that remainder is equal to 0, it is even. So say you had the number 10 modulus 2, well, there's no remainder there because it goes in evenly. Otherwise, it is odd. And again, look at this. We're looking at our if-else statements here. If our number isn't even, then it's odd, and we fall out to our else statement. So again, pause this video here, update these values inside of here, run this until you get our expected output that I have here. Hopefully you paused it there and finished that out, but let's go ahead and take a look at my suggested solution. Here we are. Since we want to start at the number 1, we don't want to start at 0. I set my control variable equal to 1. I put in less than or equal to 10. You could easily say, well, less than 11 if you wanted to, but I knew I wanted to stop at 10. So while our number is less than or equal to 10, and then I did plus plus for incrementing because we want to go exactly 1 through 10. In fact, let's see if I can bring up my window here. Let's go into this folder here and solutions. And if I run even odd, I do get my expected output there. That does it for this lesson here. Let's go ahead and close this out, and I'm going to minimize this, and let's go take a look at our next one talking about for each loops. Now, we just talked about for loops, how we can use that to iterate through a list or array, or a grouping of some type of item there that's in order. Another way to do that is using for each loops, and there's a couple of different variations of our for each loops. The first one is just the keyword for each. Let me close this out here also and get this out of the way. Now, as we just saw with for statements, we relied on a counter or an index. We had a control variable and then a conditional statement to determine how many times we execute that for statement. With for each, you don't have to worry about any of that. You just say for each this, and it will continue until there is nothing left to evaluate. Let's go take a look at what the syntax looks like and its different components. We have the for each keyword. We have our open and close parentheses here. And then we'll start at the second half of here. Our collection variable here is the collection or the array or the items of things that you want to go through. So that's the whole thing. And then you have your current item that you want to evaluate inside of the curly brackets here. Now, when you define this variable here, you don't need to define it earlier in your script or anything. Just putting it right here within the for each statement, PowerShell will create that variable for you, and you don't have to worry about defining exactly what it is beforehand. Let's jump down and take a look at an example of this syntax and for each in action. Here I have a names array. Now notice I also don't have the @ sign or the open and close parentheses. This just is another way to define arrays if you want to. I have a list of 4 names here. And then I have my for each keyword. I have my collection, which is names array. And as I iterate through each one, how do I address that current item or that specific item? We'll do that by just $name. And then all I'm doing is outputting that to the screen here inside of my curly brackets. So let's go through and run this, and we can see it just outputs each name inside of my array there. Again, we have our collection that we want to go through, and then how do we want to refer to the current item that we are working with? That's this first variable here. In comparison this to our for statement that we just looked at, we don't have to increment anything. We don't have to define something and create a condition here. It just knows there are 4 items in this array. We're going to iterate through each one until it's gone or until we get to the end of it. And then how do we address each item in the array? Our next for each loop is the for each dash object. This looks a little bit more like a PowerShell command where we have the first part dash and second part of it. Now, this is very similar to the for each statement where you iterate or go through a collection of objects and you can perform actions against each one. However, the primary difference is the for each object can be used in the pipeline. Now, the first thing I want to point out here is this for each statement or keyword here also has an alias of for each. We know that we have aliases. They can exist in PowerShell where they're alternative names for other commandlets. We saw one previously where it was get-member, but that can be abbreviated out to just GM. But if you see this for each inside of a pipeline, I don't want you to confuse it with the for each we just took a look at. They are 2 different separate commands and have different functionality. And the for each loop can also use a %sign as an alias. You'll often see this when you are typing out commands in the PowerShell prompt. It's a nice quick shortcut way to do this. Something we'll talk about later is when you're writing scripts and everything, you want to avoid using these aliases inside of those just in case those change in the future, or maybe somebody doesn't know what that alias is or exist. However, if you're just out at the command line typing stuff out, aliases are cool. That's what they're there for. They're shortcuts and just shorter ways of typing things. But just want to make sure that you know if you see this in a pipeline or you see a %sign, you are seeing for each here. And that's what's actually being used. Let's take a look at an example of how you would use this for each inside of a command. Again, we have our names array here. I'm taking my names array and I'm using the pipe symbol here. And that means I'm taking all the items in this array here, all the objects that I have, and I'm sending it over to this next command for each, and it sends it to it one at a time. You have the for each object. We then have some curly brackets of the code we want to execute against each object. And I'm just outputting a string here saying current item is $_. Now, this is something new that we really haven't gone over yet. All this does, if you see $_, it represents the current object in your pipeline. But also notice this is different from our previous for each where I don't have to define a variable inside of my loop here. I can refer to the current item as $_. If you see $_, just think I'm working with the current object inside of my loop or inside the pipeline. We'll go ahead and run this and we get the same output. Current item is each of our items here inside the array. But at some point, as we're going through the array, this $_ equaled Jeff, and then it equaled Mary, and then John, and then Heather. In our next example here, let's use our for each object to take a look at all of our running processes on our local system. For example, I'm running the get process command. It's going through, it's gathering all the processes that are on my system. And then we pipe it over to our for each object here. And then we have our curly brackets here, meaning this is the code block or the script block we want to execute. And then we're doing an if statement here. So we want to make a comparison. $_ represents my current object. And in this case, that object has properties. We learned about properties. We can access them by using the period here or a dot, and then the name of that property. All I'm saying here is let's take a look at the process name of my current object inside of my for loop. We have our comparison operator here. I'm just seeing if it starts with an A, and then I have wildcard. And if it does, I just want to output the process name. Let me go ahead and clear my outputs here. We'll go ahead and run this again. And you can see a couple of processes I have running here that start with A. This could also very easily be done using our ForEach object. We could run get process and save it to a variable, and then say for each process and all processes, do our comparison and output that to the screen. Again, just different ways of doing the exact same thing. Now, with the ForEach object keyword here, we do have the option of doing parallel processing. And all the examples we've taken a look at before, they've been very small, so they ran very quickly, but it was only processing one thing at a time. For each name and names array, it'll look at that, and then it'll continue and going through each one. PowerShell 7 introduced another parameter that allows you to run this script block inside of our ForEach object. Let me just highlight that here. We have ForEach object and our script block here. Again, this is only running one at a time, but you can run them in parallel. There is a parallel parameter, and you can do processing up into the throttle limit of how many you want it to run at a single time. Nothing changes inside of it where the $_ represents the current variable inside the pipeline or your input object. You can reference outside variables using $using and the colon. The example below defines a string variable named message with a value of processing, and then we're going to use the range operator to generate a list of numbers from 1 to 12, and then pipe it over to our ForEach object. Let's take a look at that here. We have our message here. This is a quick, easy way to just generate a list or an array of numbers, 1 ... and then another number. We're passing this over to ForEach object. We're adding in the parallel parameter here, and then our script block. And then our using statement, we're just saying processing, and then our current option here. And then we're sleeping for 2 seconds. And then I put a throttle limit of 4, meaning it's only going to process 4 things in parallel at the same time. Now, unfortunately, I do have a note here. Jupyter Notebooks don't support PowerShell 7 currently. This is trying to run in Windows PowerShell 5.1, so this actually doesn't work. But let's go ahead. I'm going to just edit this real quick. I want to grab this code here, and let's take a look at what this looks like when I run it. Here I'm out into a regular PowerShell window, and this is PowerShell 7. I'm going to paste this in and press enter so we can see 1 through 4. That's my limit, 5 through 8, and then 9 through 12. So we saw our throttle limit in place there where it only did the first 4, did the next 4, and the next 4, but it was processing all of them at the same. That brings us to the end of our ForEach topic here. I do have a small exercise where we're going to talk about an array manipulation. I want you to write a PowerShell script that uses both ForEach and ForEach object to process a list of numbers. Here is an array of numbers that I've given you, and it's also defined down in the script block here. First, I want you to use a ForEach loop to populate a new array containing numbers greater than 10. So go back and think about when we learned about arrays, how we can manipulate or add information to an array using our plus equal operator. Then I want you to take that new array and use the ForEach object to print it out, but multiply each value by 2 before displaying it. Your output should look very similar to this. We can say here are the numbers over 10 and output that. And then doubling each of these. So 18 becomes 36, 25 is 50, and so on. I do give you some starter code here. I give you the array and then just define your code below. Again, you can execute this cell and test your code as you write it. And if you want to pause the video here, give this a try, and then come back and let's go take a look at a suggested solution. Here we are in the suggested solution. Let's go ahead and go over it. First, we have the array of numbers that I provided here. I went ahead and defined a new empty array called numbers greater than 10 and use at and open and close parentheses. We first use the ForEach keyword and say for each number in all of our numbers here. Use an if statement. If our number is greater than 10, we are going to add it to our numbers greater than 10 array. We'll then output numbers over 10, and I have numbers greater than 10. If you just put an array value like that, it will output and just list each individual item on a separate line. Then I want to double each of those. We'll take an array here of numbers greater than 10. We'll pipe it over to our ForEach object keyword. And inside our curly brackets, our code block here, we're going to access the current item in the array, $_, and then multiply it by 2. You very easily could assign this you could do this calculation and assign it to a new variable, then output that variable to the screen. Perfectly acceptable. This is just a quicker, easy way. Instead of creating a whole new variable and everything, just output the calculation to the screen. And let's bring back up our PowerShell window here. Clear this out, and let's go ahead and run array manipulation. And we have numbers over 10, and then doubling each of those, and that matches up with our expected output right here. So perfect. Again, this is my suggested solution. You could have done a few extra things, like I mentioned, creating variables here, but as long as you get the same output, I think you're good to go. But just compare yours with mine here. Maybe there's some improvements you can make. Maybe there's something you did better than I did here. That's perfectly acceptable. Also, multiple ways to solve these different problems. That does it for our ForEach module. I will include a previous video that I did in this playlist and also put a link down below where I go through these ForEach loops again and talk about their performance. Some of these ForEach loops are faster than others, and there's actually one other ForEach method that I didn't go over, but just getting started here, I believe this ForEach and then the ForEach object are a great start for you when you're writing your scripts. All right, let's close this out and we will continue on and talk about our while loops. Up until this point, we've been going through for loops and our ForEach loops, meaning we had a specific number of times we were going through it, whether it was through a counter or the number of items in an array. While loops are a little different, you can put a condition on it, and it'll continue doing that block of code inside of your loop until that condition is met. We've got two variations of our while loops. The first one is called just the while loop. This continues running a code block as long as the condition evaluates to true. PowerShell will evaluate the condition prior to running the loop. And here is the basic syntax of it. We have the while keyword, and then in parentheses, we have our condition. And as long as this condition evaluates to true, we will then execute what is ever in our curly brackets here, that is our code block. With while loops, very important, it may never execute if the condition is not met. This example that I have right here demonstrates a loop that never executes because the condition evaluates to false. We have our variable number here, and it is equal to 10. So let's input this in here, and it says while 10 is less than 0. Well, 10 is not less than 0, so this evaluates to false, and our code block never runs. Just because you have a while loop and a condition here, the condition could exist where it won't ever actually execute. Continuing next, a variable is often used to test the loop condition, much like we have in our for loop, where we had to create the little variable like I or N and set it to a value. And then as you're going through the loop, you may need to modify that variable value, or you end up in an infinite loop, just like our for loops. In this example down here, we have counter equals to 1, and we're going to count from 1 to 5. While counter is less than or equal to 5, we're going to output counter to the screen. But what's very important here is we need to increment our counter. That way we don't end up in an infinite loop. Let's go ahead and execute this cell here. And we can see counting 1 to 5, 1, 2, 3, 4, 5. Perfect. Let me switch over to my PowerShell window here, and I went ahead and pasted that code in here, and we can see it does the exact same thing. We're counting 1 to 5. But if I bring back up my while loop here and I take out my counter increment, actually, let me back up. Let's go back to counter equals 1, and then we'll go back into here. And if we take out our counter increment and go ahead and run this, and as you can see, it just keeps running forever. It never increments the counter and it never meets the condition, and the loop just continues going. This is where you want to hit Control C, and it's going to break out of that infinite loop there. Very important to increment your counters or make sure you're doing the right thing to evaluate your condition again. That takes care of our first while loop. Let's go ahead and continue and taking a look at two others that are very similar in what they do. The next one is the do while loop. This one is very similar to the previous one, except it executes the code block at least once before the loop condition is evaluated. As we just saw back up here with our examples, this condition could immediately evaluate to false, and this code block would never execute. However, with the do while loop, the loop will always execute at least once and then does the condition evaluation. We have our keyword do, we have our code block and curly brackets of what it will execute, and then we have while and then evaluates the condition. So while this condition evaluates to true, this code block here will continue looping through and executing. Very similar to your while loops, you'll want to use a counter variable to control the loop condition. Otherwise, this condition may never, evaluate to false and then, exit out of the block there. Let me go ahead and clear my cell outputs here, and let's take a look at our example. We have our count variable equal to 1. We are going to do this block of code first. We're going to output our count, then increment our count by 1. And we are going to continue doing this while count is less than or equal to 5. So the first time around it's 1, we increment it, it becomes 2, 2 is less than or equal to 5, that's true, and then continue looping through. So let's go ahead and execute this code block, and it outputs there count 1, 2, 3, 4, 5. These do while loops are good for gathering user input during execution. What it will do is you can have it loop continuously until the user inputs the correct response. Here in our example, we have the do keyword again. And do you wish to exit? Enter Y to exit or any other key to continue. We're going to use read host to prompt the user to input something onto the command line and then put it into lowercase and save it into response. While response is not equal to Y. Let's say you had some code executing here and then you prompt the user, do you want to exit now after this is done? You're like, no, not quite yet. So you enter in no, and it should no is not equal to Y. That's true. Then it should go back there and continue looping until you enter Y, and then it exits out. Very similar to the do while loop is the do until loop. The do until loop will continue executing whatever is inside its code block until the condition evaluates to true. Again, we have the do keyword here, our code block and curly brackets until this condition equals true. Previously in the do while, we're doing that condition while the condition equals true and then it falls out into false. This time we're doing something until it equals true and then we'll exit out. Let's take a look at our code example here. It's very similar to the one we have above. This time we have count equals 1. We're outputting that and then we're incrementing count, but then we're doing this until count is greater than 5. If we want to output 1, 2, 3, 4, 5 like we did above, this time we have to go until count is greater than 5. If we run this here, we get count 1, 2, 3, 4, 5. Let's go back to our do while loop and take a look at its condition there. We are doing this while count is less than or equal to 5. When that evaluates to false, we then exit out of the loop. But here in the do until loop, we are doing this until count is greater than 5. That's where it can get confusing. You could come in here and say greater than or equal to 5, but I think that would stop at 4 there. Let's go ahead and give that a try here. Let's say greater than or equal to 5. And in this case, it only counts out to 4. So you have to change your conditions there and maybe mess with them a little bit depending on which loop you are trying to do there. The do until and the do while loop are very, very similar. You may have to just change your condition there if you're switching in between the two. That does it for our looping structures there. Let's go ahead and take a look at a couple of exercises I have available here. First one is a countdown timer. And in here, I say to use a while loop to create a countdown timer from 10 to 0. Unfortunately, in my code and everything else, I started at 5, so just ignore that. Printing each number in between. After the countdown timer is complete, print a message that says countdown complete. Your output should just look something similar to this, where we're counting down and then saying countdown complete. I do have a hint here of the start sleep command to create a short pause. If you're not familiar with this command, it just pauses execution of your script, and you can specify that in number of seconds. I would put this in the loop just to slow down, because if you just run it, it's just going to go straight through very, very quickly. You can do that if you want, but starting sleep and adding the second there kind of puts a little pause and lets you watch it there. Again, don't forget to update whatever your control variable is so your condition will evaluate correctly. And then down here, I get you some code to get started. I started you at 5. You can put it to 10 if you want. You need to figure out your condition here, write your code, and then at the end, it'll do countdown complete. So you can, right here again within this cell, update this and then run your code to figure it out. If you want to try this, go ahead and pause the video, give it a try, and then let's go take a look at a suggested solution here. Okay, in my suggested solution, we have starting at 5, and I said while this variable is greater than or equal to 0, because I want to count down to 0, we'll output the value of the variable. I'm going to sleep for 1 second, and then I'm going to decrement because I want to count down backwards. So we'll do minus minus. Let me open up a window here and let's go ahead and just run countdown timer and see this in action. We see 5, 4, 3, 2, and then 1, 0, and then countdown complete. All right, that does it for our first exercise. Let's go ahead and close this out, and let's go take a look at another exercise here where we're going to add together a sum, some random numbers. I'm going to give you the option. You can use a do while or a do until loop. And I want you to add together some random numbers between 1 and 10, stopping when the sum reaches or exceeds 30. When you go through the loop iteration, display the random number being added and then what your running total is. Your output could look something similar to this. So I'm adding 7, or going back, you're starting at 0, you're going to add 7, and then your total is 7. 7 plus 5 is then 12. 12 plus 2 is 14, and so on. And then at the end, once you've reached 30 or higher, just put out some message that you've reached it and you're exiting the loop. To generate random numbers, you can use the get random commandlet here, and then you can specify your range of numbers that you want to generate from. So we have minimum, maximum between 1 and 10. I've got you started here with the partial solution. We're going to say sum equals 0. You're going to do this at least once in the loop. And we do know, generating a random number, you're not going to generate anything higher than 30 or higher than 10 to sum up to 30. So put your code here and then pick either the while or the until and put your condition in. And then I have my end message here. Again, go ahead and pause the video, give this a try if you want to, but let's go take a look at my suggested solution here. In my case, I got started here. We've got sum equals 0. We're going to do, I'm generating a random number here. I'm saving it to its own variable, get random between 1 and 10. Going to use the plus equal operator to add this number into sum. And then as we iterate through, it will re-add it to our ongoing sum and then our additional random number there. I'm adding a random number and then outputting my total so far. And I went with the until. We're going to do this until our sum is greater than or equal to 30. Go ahead and bring our window back up here. Let me clear the screen. Let's do some random numbers and watch it go through. Adding 5, our total is 5, 7, 7, and we got all the way to 34. If I run this again, we should get different numbers. 7, 8, 8, 4, 6. Okay, that does it for our while loops module here. Let me go ahead and exit out of all of this, save our changes, and let's go on to our next component with our switch statements. Now, switch statements are very, very interesting. They're very useful if you want to replace a bunch of if, else if, and else blocks. It can be a cleaner way to handle multiple conditions. The switch statement will check a condition or the expression once and then compare it against a list of possible values. When a match is found, that code block will then be executed. We have a couple of components inside of our switch statement. We have the switch keyword, an expression to evaluate, and then one or more possible values to match. And at the end, you have an optional default that will execute when another value matches. You could think of the default as an else in our if, else if, and else blocks. It just evaluates at the end if nothing else matches up. Looking at our syntax typed out here, we have the switch keyword, our expression that we are evaluating, and then our list of possible values that we want to match against. And then in curly brackets, we have our code block to execute. So again, we have our expression. This is one possible answer. This is another possible answer that it could match to. And then our default that will execute if no other value matches. Let's go down and take a look at an example just to give you a better idea of what this looks like. We have a variable called color, and I'm initially setting it to red. We have our switch keyword. And then what are we evaluating? In this case, we are evaluating the value of our color variable. And then inside of our code block, we have potential options here. Our first one is red. And if that is accurate, if that matches up, we're just going to output the word stop. If our color is yellow, we'll put caution. If it's green, we'll say go. But if our color does not match any of those, we will just output unknown color. Let's execute this code block and we should see the word stop. If we go through and update this, let's say yellow, we'll get caution. We'll update this again to green, and that should say go. And then if we put in a color that does not match any of our options, let's say purple, it will come back and say unknown color because it went into our default option here at the very end. Now, matching up just a specific value here, like our strings, is pretty great. But what if we want to do some type of comparison when we're evaluating, whatever we've got in here? You can make comparisons using $_. We saw this when we were looking at our ForEach object loop before. That's just the current object in our pipeline, or what, in this case, what's coming out of the switch statement. In our example down here, when we say number and then switch number, this is the same thing here. These are the same values. Number here is now represented by $_. Let's take a look at this example code here. We have number is equal to 10. We want to do a comparison on our number here. So we know this is 10. And then we have our number here in our first comparison. Notice our comparison this time is in curly brackets. Up here before, we just had this string in quotes, but this time we're doing a comparison. It's inside curly brackets. Is 10 greater than 0? Well, that is true. And then our code will output here that the number is greater than 0. Is it less than 0? Or is it equal to 0? In this case, I don't have a default statement because these three should evaluate. One of them should evaluate here, is the number greater than or less than 0, or is it actually 0? I suppose if we put this in a string here, that wouldn't evaluate correctly. And, that's where a default might come in play. But in this case, it should match one of these if we stick with numbers. Let's go ahead and evaluate this. It should come out and say 10 is greater than 0. Perfect. Let's say -5. -5 is less than 0. That went through into our second option there. And if we actually put in 0, it should hit that third condition. Now, this is interesting. Look what I did here on accident. And this is a good point into our next topic here. When we get into here, 0 is less than or equal to 0. That does evaluate to true, and that output this. But now 0 is also equal to 0, and we can see it also output both options here. I forgot I did this on purpose to kind of introduce the next topic. In this case, one, this is a syntax issue here, or a logic issue here. This should be less than 0, and that then would evaluate correctly. 0 is 0. But What happens if there's an opportunity for you to evaluate and potentially match existing ones here, but you only want it to match the first one? The switch statement will continue executing all the way through. That's a little bit different than our if statements. We saw where if this one equals to true, then the rest of them don't follow, or maybe an else if equals to true, it won't evaluate the rest of them. Inside of switch statements, it will continue going through and executing unless you tell it to stop. And in order to do that, we use break to stop the execution. Here in our example, we have number equals to 10. We're going to perform a check on it. So we have 10 is greater than 10. No, that's not true. Is 10 greater than 5? That's true. Is 10 greater than 2? That's true. So we should see two outputs here. Greater than 5, greater than 2. Okay. But if we want to stop at the first match inside of our evaluation here, we go in and add the break keyword. Usually, when you're working in switch statements, your code block here is usually pretty short. Maybe you're just assigning a variable or taking an action on it. You'll typically see these maybe on one line. And if you're not aware of it, you can use a semicolon to indicate a new line or essentially separate your PowerShell commands. We could very easily put these on multiple lines inside the block, but just let you know that's why this semicolon is there. But what this is saying is, as if this evaluates to here, we're going to say break and then exit out of our switch statement and not do any more evaluations. So let me pull this back up here. You can see that these two examples are essentially the same, except this one has a break. And before we got an output of greater than 5, greater than 2. But this time we're only going to get the output greater than 5 because this one evaluated here, it said 10 is greater than 5. It output our greater than 5 message. And then we told it to stop and don't continue iterating through our switch statement. Just remember, switch statements continue to execute. And if you want it to stop, put in your break keyword here at the end of your code block. So far, we've been doing exact matches with our strings and then doing comparisons with our numbers. You can also use wildcards to do comparison. In this case, we have file name equals report. We have a file here. We're doing switch, and you can add the wildcard parameter here on file name. And we have a wildcard or asterisk here, .txt. This is a txt file. And then we're checking to see, is it a CSV file or is it an unknown file type? If we come in here, if we execute this, it should come back. This is a text file. If we change this to CSV, this is a CSV file. And if we do something in here that we don't know, we'll say bat for batch file, but we're just going to say unknown file type because that did not match either of our wildcard statements here. Let me go back and switch this back to text. You can also use arrays with your inputs on your switch statements, and the switch statement will automatically loop through each element in the array. This is something I actually learned putting this material together. I did not know this was possible. So this is a fun, exciting one. We have our fruits array here. We've seen that before, apple, banana, and cherry. We're going to switch on our fruit array and then look for potential matches. So the first time it goes through, it'll say apple, our string apple equals apple, and then output I love apples, bananas, and then default. If it doesn't match anything that we have our conditions here, it's just going to output some other fruit. We run this, I love apples, bananas are great, and then some other fruit, I don't care. Because our third option there, our third item in the array is cherry. Haven't ran into a use case for this yet, but very interesting and I like it. Something else also learned putting this material together is you can do switch statements and use them for variable assignments. You can set a variable based on the result of a switch statement. Let's say you want to set a number based on a variable being evaluated. You can then take that switch statement and assign it to a variable using the equal sign. In our example here, we have the color blue. Now let's ignore this for a second. We still have our switch statement here. We're switching on color. We'll say if it's blue and then just output 5, yellow is 10, red is 15, purple is 20. Anything else is defaults. However, we can take the result of this switch statement because we're just outputting things here into the pipeline, I guess, or into the console. And we have the assignment operator here of equals and then assigning that into number. And then down here at the bottom, we're saying the value for number is number. If we go through and run this, The value for the number is 5. This is because our color was blue. Blue was our first option here, and we outputted 5 here. If we were to switch this to red, we should output 15. Again, very interesting. Haven't ran into too many use cases for this, but definitely very cool and just a little fun tip or trick there. Next, let's go into our exercise for this lesson here. What I want you to do is create a switch statement to categorize an array of numbers as small, medium, or large. Small numbers are 1 to 5, medium are 6 through 10, and large is 11 or higher. I want you then to print the number and its category, and if a number does not fall within the range, print the number is not within a category. The output should look something similar to this. We'll see the number 2 and its category is small, the number 7 is medium, 12 is large, and as we go through, the number 0 here is not within a category because that doesn't fall within any of these ranges. Do have a little hint here. You can do compound statements inside your switch statement evaluations using the AND. We've seen that before as we've gone through if statements. And then I have the starter code here. I give you this array of numbers here. We're going to switch on the numbers, and then you need to build in the switch evaluations here, and also hint using a default. So go ahead, pause the video, give that a try, and then whenever you're ready, we'll go into my suggested solution here. Okay, here we go. We've got our number array. We are switching on numbers. It's going to go through and evaluate each one. And we have our first statement here that we are evaluating. This is where the AND operator comes in to create those compound statements. Is our current one greater than or equal to 1, or is it less than or equal to 5? That was our range for small numbers. And we're going to output the number and its category. Another compound statement here, if it's greater than or equal to 6, less than or equal to 10, that's our medium. At this point, we don't need a compound statement. Is our number greater than or equal to 11? Then it's a large number. And then we have our default. This number is not within a category. Go ahead and bring up our command window here and clear this out. Let's go ahead and do number categorizer and make sure this comes out exactly as we are expecting. Perfect. There we go. All right, that finishes out our final lesson here inside of this module. Let me go ahead and close all this. Not going to save that. And let's go into our challenge for this module here. What I have here is I want you to create a number guessing game. You're going to challenge the computer and try to guess what number it is thinking of from 1 to 10. Inside of the script, you should generate a random number between 1 and 10. We talked about that before of using the getRandom commandlet. You'll then prompt the user to enter a guess of what they think the number is. What you'll need to do is convert the user's input using read host from a string to an integer. And I do give you that code here. An example, you'll read host prompt guess a number, and you're going to strongly type the response using the int keyword here. You'll then need to tell the user if their guess is higher, lower, or it matches the random number that it's thinking of. I have what I think the script output should look like. You can obviously customize this a little bit. Output, let's play a game. I'm thinking of a number from 1 to 10. Can you guess which one? And then we've got our prompt here for read host, guess a number. I put in 5. Your guess is too low. Try again. I put in 8. Your guess is too high. 7 and then 6. Finally get the guess correctly, and then the game should end. Now, unfortunately, before in our exercises and challenges, I did give you your own cell here inside the Jupyter Notebook to generate and write your code. But in this case, Jupyter Notebooks don't support or allow user input using read host. You'll need to go create a PS1 file and put your code in there and then run that PS1 file in order to test your solution. Here's a little code snippet I've got written out to get you started. We'll put in answer and then get random minimum 1, maximum 11. Now notice I said a number between 1 and 10, and I said inclusive earlier. What's interesting about this sometimes, and I see it in .NET also, is if you do something like get random, you put minimum. That means it starts at 1, but then maximum is not included. Since I said maximum 11, this is actually saying 1 through 10, excluding 11. Not sure the reason behind that. I'm sure there's one written for the, of why it does that with the class or method or anything like that. But just know if you're doing maximum like this, you need to go one higher if you wanted to include the number 10 in this case. We have a control variable here of game over equals the Boolean false value, outputting let's play a game and think a number between 1 and 10. Can you guess which one? And then start writing your code here where you're going to prompt the user for their guess and then evaluate based on their response and go from there. Okay, so go ahead and give that a try whenever you're ready, and let's go take a look at my suggested solution here for our number game. Okay, let's go through my solution here. We've already seen this top part that we just saw. What I did was a do until loop, so I have my do keyword here, and I'm doing until game over, which is our control variable here, equals true. So let's think about this. Whenever we're evaluating the user's response, we need to say if they get it right, we need to switch game over being equal to true. So our loop will exit here. Inside of our do loop, we're going to prompt the user to guess a number. This is inside parentheses here. We're going to read host and give them a prompt, guess a number, and then convert that into an integer here and store it into guess. Going to do a switch statement on guess and take a look. Is our guess greater than the answer, which we generated up here? If that's true, your guess is too high, try again. If it's less than our answer, it's too low, try again. And then if it equals our answer, you guessed correctly. And then once we know that, we need to switch game over to true. Then our do until loop, it will evaluate and say, oh, we're going to do this until our game over equals true, and then exit out. Let's bring our command prompt window back up here, and let's give this a try. Comes out, let's play a game. Think of a number between 1 and 10. Can you guess which one? Let's go ahead and start with 5. That's too low, so I need to go higher. Let's maybe go 8. Okay, that's too high. Let's try again. So we got 6 or 7. Let's go 6. All right, guessed it correctly, and then our game is over. Clear out the screen. Let me bring this back up here. Let's try it again. We'll start again at 5. It's too low. Let's go with 8. Still too low. 9. And then it's 9. Perfect. So you can sit there, little number guessing game, putting in the logic of our loops and our switch statements. Again, you could do while loops, but you want it to run at least once. So I would suggest using the do until or the do while. Now let me exit out of this and let's go back to our lesson here. And I do have a bonus challenge a little bit. That was a pretty basic version of our game. You could sit there and guess as many times as you want to, but what I wanted to do is just give you some additional challenges, some additional thoughts if you want to enhance your game here that you're creating. You can limit your number of guesses before you end the game, display an appropriate message if they run out of guesses, so determine how many guesses you want the person to take. Keep track of previous guesses and display these to the player and prevent the player from repeating those guesses. Add a play again option so the player can keep playing. If adding this one, consider tracking the number of games the person won and lost and display those stats maybe to the player. And then maybe add in a difficulty level for guessing the random number. You could say easy, medium, or hard. I'm not saying you have to implement all these, but if one of these stand out to you, see if you can work through and add this into here. And then I did go through and create a script that actually implements all of these. Let's go take a look at it. This ended up being a lot more work than I thought. I was like, oh, these would be exciting things to add to the game. And then I got in here and was like, whoa, this is a lot more than I expected. We'll kind of go through some of these, but maybe not all of them, but let's just go through some of the logic here. First, I'm setting what difficulty level I want it to be. Let's say it is medium. I'm doing a switch statement on that medium and then generating the maximum range of the number I want to generate. So easy, medium, hard. We have 11, 51, or 101. I defaulted to easy. We're assigning that to maximum range. So whatever this evaluates into, we're going to say maximum range. Then we're going to set the maximum guesses based on our maximum range, switch maximum range. And then if our maximum range is 11, we're only going to give the person 4 guesses. If the maximum range is 51, then 6 guesses. If we're doing 100, 7 guesses. We're keeping track of games won, games lost, and a play again variable, which we're setting to Y initially, and then outputting let's play a game. In this case, let me scroll all the way to the bottom. I'm doing a do until loop until play again equals 0. So this is why I set play again to Y initially, because I want this to run once, and then we're going to wait and prompt the user later to see if they want to play again. And until we're going to do that until play again equals no. Going back to the top here, we're going to play the game. Again, we're keeping track, is the game over or not? Meaning, did I get the correct answer here? And then we're going to generate our random number using getRandom, and then our maximum range, which we determined earlier. I'm keeping track of our guesses here. Must have been doing this for debugging purposes, so just ignore that right there. All guesses, it's an array, and then my first guess count, I'm starting at 1. Then I'm thinking of a number between 1 and I have to subtract 1 from my maximum range, so say 1 to 10, 1 to 50, 1 to 100. Can you guess which one? Inside of this, I have another do loop. Let's take a look at what it is doing. We're doing this until the game over equals true. So pretty similar to what we did before. We're just prompting through, giving people guesses until they get the answer right or they run out of guesses. I'm looking at all guesses. That's the array where it's keeping track of previous guesses. If this count is not equal to 0, that number has already been used, and doing some formatting here of my output and everything. But then we're prompting for guesses. Oh, sorry, this is where I'm keeping track of the numbers I've already guessed and just outputting that. So at this point, if our array of all guesses, if it has some item in it, then the count is not equal to 0, and that's outputting it there. We're prompting for the guess. If our guess is in our range of numbers, we are going to evaluate it, but I'm going to skip that for just a second. If I guessed, if I'm on easy and I put 1 through 10 as my range, but I guess 15 instead, this handles that error where it then says, hey, what you just tried there, that number is outside the maximum range. Why don't you try to guess again? If I did put something in the range, if my current guess is not in something that I've already guessed, a number, we're adding that guess, my guesses array, where I'm keeping track of those. And then finally, we're going to evaluate, did I get the right answer or not? Very similar to what we looked at before. You guessed correctly. We've got game over equals true, but then I'm also adding 1 to my game's 1. And then coming back down here, if my guess count is greater than my maximum guesses, meaning I've made too many guesses for the range of difficulty, my game over equals true. I add 1 to my games lost, and then you ran out of guesses. The answer was this. Then we prompt the user, do they want to play again? I'm keeping track if they give me a valid response. Play again. Do you want to play again? Yes or no? I'm putting that to lowercase and then trimming any white space in case they, fat finger or type in something extra there. If the play again is equal to yes or play again is equal to no, we got a valid response. And I'm doing a do until loop until they give me a valid response here. So I'm going to keep prompting the user until they put in Y or N. And if they put in N, then that exits our complete loop, and then keep track of games won and games lost. Again, like I said, I put in all those bonus things there. And when I started writing the script, I realized that was pretty difficult. But that's why this is the bonus challenge. If you want to come in and just put in a difficulty level, make that a little bit simpler, maybe my code here will help you do that if you pick out that little part of it. I guess I could maybe come in here and add some comments to explain some of that. So if you're taking a look at it, but yeah, lots of stuff here. So real quick, let's try to play this real quick. I'm on medium. We'll keep that at medium right there. So let's bring this up, clear out our screen, number game, bonus. Let's play a game. I'm thinking of a number between 1 to 50. So we knew that because my difficulty was set to medium. Can you guess which one? And then, I'm also outputting how many guesses you get. This is my first guess. So let's say 25. Your guess is too low, try again. The numbers I've already used are 25. So this should, if I do 25 again, you already guessed that number, try again. And then I'm still on my second guess here. So 25 was too low. So it'll be 25 and 50. Let's say 26. Let's say 38. Too low, try again. So between 39 and 50, We will say 45. Okay, that's too high. As you can see, this is increasing here and showing what numbers I've already used. So between 39 and 44, let's say 42. Oh, and I got it, I guess, correctly. Do I want to play again? Yes or no? Go ahead and say no. And then I won one game and did not lose any games there. Hopefully this will show you what's possible. If you're just beginning scripting, you can really create some really neat things. It doesn't even have to be work related. You can sit here and create games like this and just start thinking about, we did the initial game here, but then start thinking about what changes could I make and just experiment with it. This not hurt anything. It's not going to change your system. It's not going to delete files or anything like that. You're just guessing numbers. And then that's where introducing those additional challenges like that and trying to figure out the logic behind it just makes you a better scripter and going through that problem solving process. All right, that does it for this module. Hopefully it was helpful. And our next module, we're going to start talking about parameters and how we can add those into our scripts to make our scripts more versatile. Thank you for watching. We'll see you in the next video.